This is the Process Control Loop Lab Unit Capstone project completed for spring of 2019. Team members are Nick Norris, Jake Morgan, Brian Dooley, and Jared Roberts. A previous Capstone team had implemented a process system including a heated control loop providing heat to the process loop, with a radiator acting as the load. Manual valves were used to regulate the temperature of the process fluid, and a PLC was used to read the process temperatures by utilizing temperature sensors on both the process and control loops. Here's the actual control and process loop. The power plant students built this portion of the project. Our team's goal was to move the control system and power control to a new controls rack, to use pneumatic control valves fitted with I to P transducers in order to control flow, to control the entire process using a PLC, and to use a new high-resolution HMI to give the power plant students a realistic operator feel. To begin, we use cable trays to run cable from the controls rack to each of the field devices. Equipment was then mounted to the controls rack and power rack. On the control side, from left to right, a click 24-volt power supply, a click PLC, a 4-channel analog voltage input, 2-channel analog voltage output module used for receiving signals from the flow sensors and sending signals to the I to P transducers for valve positioning, and a 4-channel thermocouple input module for receiving signals from each of the 4 thermocouples. Next, we have the GSD1 DC drive, which was used to control the speed of the radiator fan. On the power side, we ran all external power through breakers. We then used 4 ice cube relays for the water heater, both pumps, and the e-stop. On the very bottom, we have a 24-volt and a 12-volt DC power supply. As mentioned before, we used a click PLC to fully automate the process. Here's an image of part of our PLC program used. Here is the view inside of our HMI panel. We added a speaker for alarms. On the outside of our HMI panel are 4 switches, which are able to turn the pumps, water heater, and radiator fan to on, off, or PLC mode. These field switches will override the PLC program if adjusted. Also shown is the e-stop, which will stop the entire process. Here is our HMI screen. On the home screen, the operator is able to turn on or off the entire system. The screen selector on the right allows the operator to choose which screen they will view. In the control loop screen, a visual representation of the control loop is shown. The water heater is used to heat the fluid as the pump pushes that fluid through the heat exchange feed valve or the exchange bypass valve. When equipment is in use, it is shown with a red background and green when it is off. The flow rate is shown in gallons per minute beside the flow meters. We used a W.E. Anderson site flow indicators on both loops, which send a 0 to 10 volt signal to the PLC. The PLC is then scaled to show this value in gallons per minute. Each process valve is fitted with I to P transducers, which are actuated when sent a signal from the PLC. When in automatic mode, the PLC will open and close these valves based on set points in the program to heat or cool the process fluid. The operator has the ability to touch any field device on the screen to switch modes from auto to the manual or off position. Also shown are 2 temperature elements providing temperatures of the fluid out of the water heater as well as after it is passed through the heat exchanger. In the process loop screen, the process fluid runs through the heat exchanger and into the tank. A pump then pushes that fluid back into the heat exchanger. On this screen, the operator can also view the temperature of the fluid. The temperature elements are measuring the temperature in the tank as well as the radiator after the radiator. On the other flow indicator is the position after the pump. The temperature set points of the tank can be selected by pressing on the process temp set point. This value will be updated in the PLC program. If the fluid is above the set point, the radiator fan will come on to cool the fluid. As we move to the trend screen, the temperature trend screen will allow the operator to view the trends in real time. In the flow and valve trend screen, the operator is able to view these trends in real time as well. A flash drive is connected to the HMI, which captures this data, allowing for the storage. The screen capture button allows the operator to take screenshots of real-time trends, which is also saved to the flash drive. On the detailed settings screen, the operator is able to view set points that are in the program, but only after the change, but they're only able to change these set points by entering a PIN number to prevent unwanted changes. In the alarm screen, the operator is presented a list of alarms that have been activated due to abnormal conditions. When an alarm has been activated, the abnormal condition must be corrected, then confirmed in order to deactivate the alarm on our HMI panel. And finally is the utility screen, which will allow the operator the ability to adjust the volume of the speaker as well as the brightness of the screen. Thanks for watching.